Okay. Okay, I guess it's time to start. So we seem to have 30 minutes, so I'll try to squeeze as much of it as possible in that time. Okay, so hello everyone. So today we are talking microservices. As you've noticed, we've been talking microservices for a couple of years already. At the beginning, it was quite a lot of hype, but nowadays we tend to talk about the opposite of that. So we spent years convincing people to migrate into microservices, but now we are doing kind of the opposite, dissing microservices and reversing the titles of our presentations. So we no longer migrate from monoliths to microservices, but from microservices to monoliths, and so on. Anyway, during the last around 10 years, I've seen a couple of microservices-based projects, and it's quite interesting because you can see that there are similar patterns being repeated all over again. And today I would like to bring some of those up to your attention. My name is Grzegorz Piwowarek. I'm an independent consultant and trainer and a fresh Java user group leader. So microservices have been around for a very long time. Unfortunately, we keep repeating the same mistakes over and over again. And unfortunately, it often ends up with starting with a monolith and a big promise to move into microservices and getting better. But guess what? If you slice your brew into smaller ones, suddenly your surface layer gets bigger, and you might end up with something that's even worse than it was before. You can slap a lot of tech on top of that, like a service mesh, but at the end of the day, yeah, it won't fix the problems of your design. Long time ago, there's this guy. This guy actually invented null. So all your null references, null pointer exceptions is his fault. And in one of the interviews, he called it his $1 billion mistake. So if he didn't make that mistake, that's how world could look like. But unfortunately, he did that. Why I'm telling you that? I think there is another $1 billion mistake here in play, and that is microservices. But don't get me wrong, it's not about microservices, but microservices. So that name, the micro in the name, the differentiation of microservices from software-oriented architecture, service-oriented architecture, suddenly made people start asking questions and obsess about the size of microservices. So how is that microservice different from a service, actually? And how do you measure that? How small micro is? Do you measure it by using lines of code? Do you measure that by relying on the number of classes? Megabytes? Probably one of the best metrics I've seen is your service rewritable in a certain amount of time? Some people would say 1 week, some people would say one day, whatever, but it's pretty decent. But the thing is, it's really hard to provide an actual value that tells you, okay, this is the perfect size of your microservice. However, there are some good indications of when you can actually perform a split. But before we jump into that, let's recall the main idea of a microservices. The main idea of microservices is not to have a lot of services by itself, and that's what I've seen in multiple projects. So not a long time ago, I've joined one. There were like 6 people working there. They created 80 services. And I was doing an internal audit in that team. And when I started asking questions about how many customers they have at their architecture, they seem to be very proud that there is 80 microservices already being done. And they were very eager to say that we are going to increase the amount to 150. And like, but, okay, wait, folks. How many of you are in the team? 6. Okay, how many customers do we have at the moment? What traffic, what kind of non-functional requirements we are dealing with? They said 1. Okay, but 1, yeah, million, billion, thousand per day, per second. No, 1, like literally 1 customer. And to give you more details into that wasn't a high traffic system. That was literally a system where you do one operation, you create something once, you create a resource once, and then you update it not once per second, not once per day, maybe once every couple of weeks. and so on. The main idea of microservices was to enable scalability through independence and modularity. And that's about scalability not just when it comes to number of requests per second. A request per second you can process, but also when it comes to scalability of the software engineering organization. Because one of the big challenges when it comes to the software is that even if your software scales really well, so let's say your software can suddenly one day handle 10 requests per second, but next day seamlessly scale to 10 million per second somehow, you will have different problem. Because probably if your software scales really well, you'll probably need to put more people on that because the business will grow. And so now it's totally different when you have 5 people working on a problem and when you have 50 or 100 or 500. That's totally different. And microservices is one of those great ideas that helps you with that. And it helps you by helping you get your modularity right. So think about classical monolithic application where you didn't really pay attention to modules, boundaries, encapsulation, and so on. You probably have quite a lot of features intertwining and relying on each other's implementation details. So the whole point is to arrive in the place where you divide and conquer. You have your software composed of features, composed of modules. They all do the same thing, but talk only via public APIs, or at least via APIs that are much narrow in surface, so that you are free to do whatever you want with implementation details of every of your components. The same idea applies to microservices itself. So you can think about each of those groups as each microservice. But you can do the same inside one service. So before you get into splitting everything into small services in order to get modularity, that's what you can do inside your own application. That's a Java example, but that works with pretty much any other language out there where you can have directories. Naturally, this won't give you all the benefits of microservices, but this is pretty cheap to implement, and you can already see some benefits from having this honeycomb-like structure of your services. So when you think about going from monoliths to microservices, usually it would be a good idea to have this step in between, where your big spaghetti-like monolith becomes honeycomb-like modular monolith. And eventually you pull those things apart when you really need them, or where you really need to, and then this suddenly becomes microservices. However, beware. So even Sam Newman, the author of the original microservices book, says that if your microservice becomes so smaller, you'll probably maximize the benefits and downsides of microservice architecture. But there is one important note. If your services are really, really small, probably you are experiencing more downsides than benefits of such setup. So let's have a look at a couple of popular architectures out there. So that's, for example, a graph of Netflix microservice architecture. As you can see, it's pretty fine-grained. The important note is that they didn't start with that. They started with probably a couple of them. That's something that they arrived to after many years of constant evolution and hiring over 2,000 engineers. Nowadays, it's kind of hard to say because they probably fired some of those. Anyway, so when you look from the pragmatic point of view, you shouldn't probably ask about the size of the ideal size of a microservice or so on, but when to split. So normally you would already start with a modular monolith. At some point you'll start experiencing some pains. And if those pains become unbearable, that's when you do the split. But you don't split one into 150 suddenly, but probably 2, 3, or so on. And then if you are still experiencing some problems, then you split again. But again, not to 150, but one by one, until it's finally manageable. So the whole idea is to don't prematurely split, but only when you really need to. And that's the first rule for distributed systems. They are really cool, but at the end of the day, this is the cool stuff. But when it comes to maintenance, that's not fun. So if you can defer jumping into the world of distributed systems, just avoid it as much as possible. So now let's start thinking about the pragmatic default. So when you jump into a new, if you probe all microservices-based systems in the world, I would assume that the expected value would be to have something as the HH called the majestic monolith. So that's the evolution step between modular monolith and microservices. So probably it is the moment where you've modularized your monolith, you've started splitting it into smaller ones. So probably there is one or a couple of bigger services around the place, and a couple of tiny, auxiliary orbiting services that are that needed to be pulled out from a monolith. And that sounds like a pragmatic, where it's a place where you kind of hit the optimum, where you maximize the benefits of microservice architectures without really maximizing the downsides. However, if you want to be successful, you also need to think about doing something more. Because if you split your code base into smaller parts and you deploy it now in separate chunks, that's not enough, because old habits die hard. So for example, single version for all services, a classic. So you split your monolith into smaller ones, but you kind of mentally don't want to let go of that. So you version all of those at the same time and try to release them all at the same time. At the end of the day, there is not much value out of that, because the whole idea is to be independent. You want to have independence per module, per service, so that, for example, you can redo your organization so that there is team ownership and separate teams managing separate parts of your system. But if you still tag all of those at once, if you deploy all of them at once, if you need to synchronize all of those teams to say, okay, agree on the when do we freeze and when do we release everything, well, that doesn't sound like you get much value out of that. Another classic story is that you build a separate DevOps team, you put it on the side, and suddenly there are multiple teams, well, maybe working independently, but suddenly that there's a separate team responsible for actually delivering that to production. So they quite often become a bottleneck. The better setup that I've seen working is that when you take this team apart, you put them in those product teams, and then they are working as a part of the product team, and their job is to deliver as fast and safe as possible. So suddenly that ended up working much better than separate team that suddenly is responsible for making sure that microservices are getting right deployed. Another problematic thing is it's kind of hard to end-to-end test things if you go distributed. Well, if there are just a couple of services, that you might be able to do that. But think about the Allegro scale, or eBay scale, Amazon scale. If you are having thousands of services, do you really believe you can test everything at once, end to end? At some point, there is a breaking point where you need to just let go of it, because it's not possible. Even if you try doing that, imagine having a couple of teams working together on, let's say, 150 microservices. And so you start testing them end to end. Those tests will be really slow, so don't expect it to complete fast. It's quite likely some of those teams will have delivered a new version of the service before the tests finish. What do you do then? Do you restart the tests, or trust that maybe this module works with everything? So at some point you will end up at the scale where it won't be possible, because tests will be so long, and you will just keep waiting for those to complete. And they will effectively never complete, because before they complete, there will be a new change ready to be shipped, and that needs another end-to-end testing. So my point is, at the end of the day, if you can't make a change to a service and deploy it by itself without changing anything else, you will probably not experience most of the benefits of microservice architecture. And that's one of the sentences that you can find at the beginning of the original microservices books. Another classic things I'd like to bring up to your attention, that's monorepos. And so there's been this religion war between monorepos and repo per service approach. How do you organize those? And there are certainly examples of companies that make both work right. However, there is one tricky thing. So be careful when you read about articles that Google, for example, they do monorepos and they are fine. Monorepos will require you to build quite a lot of dedicated tooling if you want to have some independent versioning, independent Git tags, independent build processes that can, look at your pull request, identify the change, and build only those that have changed. But I have bigger problems with monorepos that I've seen not work really well. Monorepos make it really easy to stick to old habits. So now, at the beginning, you've had this monolith, all the features put in one big jar file. You make a pull request that pretty much touches all of them at once. Well, and you can make it work because, well, it's still one application. But now, if you put multiple modules and you put the services into one repo, suddenly it's possible to make atomic pull requests to all of the services. But guess what? That's really hard to pull off in real life when it comes to deployment, because suddenly you would need to synchronize all of those deployments at once to make sure that works. So if you have monorepos, it creates space for you to make mistakes like that. That's why I personally go for repo per service, because there's no way. You can't make an atomic pull request across multiple services. And you are forced to work with them in such a way that it's safe to deploy with backward compatible manner. But if you make one big pull request to monorepo, well, that will work. But good luck with the deployment. Another classic problem I've seen is the not embracing eventual consistency. So you've had your monolith. You did split it into 1,000 services, but suddenly all of those services, they need to be up and running at the same time to serve, to do the work. And at some point, it won't scale really well. So you might be experiencing troubles because the more components you have, the more they can fail. And if they can fail and if they can bring your whole system down, that's not a good idea. So at some point, the more nodes you need to synchronize, the more it makes sense to let go of strict consistency and start embracing eventual consistency. So the whole point is that at some point you might need to replace your classic HTTP calls with event-based processing. So instead of you calling other services and asking for something, you could be introducing event-based solutions, which involves one service, the other service communicating to others about the event that has happened, and you, as the consumer of that event, you build your local projection in your own service. So when the service 2 goes down, you still have access to the local data. Well, guess what? It's eventually consistent. So it might be lagging. It might be lagging, a couple of milliseconds behind the source of truth. It might be lagging, a couple of days. But eventual consistency gives you guarantees that at some point in the future, it will catch up with the source of truth. And if you can spot areas in your system where, for example, analytics, if you are thinking about analytics, probably you don't need this to be processed in real time, but let's say you're processing the days that already passed. Well, then probably you can survive this hiccup of a delay of a couple of seconds of eventual consistency. But when you spot those, if you can spot those areas in the system, and if you can make it work, your system will be way more resilient, because suddenly the service 1 doesn't have temporal coupling to service 2. Service 2 can be down, but service 1 can still do its job. But keep in mind that eventual consistency is not accidental consistency. So a classic scenario, when you start to embrace eventual events in your system, well, the classic situation that happens is that, imagine you have a user service and someone creates a new user. So obviously you would save this entry to a database, but then you'd like to communicate to the whole world that, well, we've just created a user. So So naturally you use another line of code and you try to send it, to RabbitMQ, Kafka, or any other tool that you would like to use. But this is a very problematic part, because suddenly you can't really enforce transactional guarantees when it comes to dual writes to those two sources. Well, you can put transactional in there, but it still doesn't make it suddenly distributed. So think about a scenario where you persist a user to a database. The transaction is still open. Then you send something to RabbitMQ, and the RabbitMQ accepts the event, but the ACK from RabbitMQ gets lost somewhere over the network. So your RabbitMQ client throws an exception, the transaction gets rolled back, and guess what? Suddenly you have a data that's not stored in database, but event that was published already to your whole system. So we have this ghost user-created event, and that's not ideal. So that issue is called dual write. Essentially what we need to do here is to have a distributed transaction. You can kind of do that if you really want to with two-phase commit, but this is pretty tricky, and you still need to rely on the transaction coordinator that needs to be up and alive all the time. But there is a better way to do that. That's pretty optimal. So consumers of messages from Kafka, they don't get them immediately. Again, this is eventual consistency. They get them with a delay. So what you can do is that you can replace that single write, those two writes to database and to Kafka or to RabbitMQ, whatever. You can replace with single write to a database, and then use either transactional outbox pattern or change data capture, which can be as easy as having a separate message relay component that polls new entries from a database, every couple of seconds, and then puts them over to Kafka. And this is a really easy piece of code, but gives you suddenly those guarantees that you consumers of your messages, they will receive them at least once. In the previous case, it could be at most once, and that's often not acceptable. And one of the last things I'd like to talk to you about is technology zoo. So one of the promises of microservices is that suddenly, once you have separate components, you can write those using different technologies. So suddenly you can, but it doesn't mean you need to. So you've been writing in Java, but now you can, come on, you can do one microservice in PHP, second one in Rust. And yes, you can do that, but in most cases you will probably experience pains of managing various technological stacks instead of dealing with just one. So this sounds great on paper, but I would advise you to just don't throw in new tech unless there is a good reason for that. So most companies will probably benefit from standardized tech stacks, with occasional experiments. So now suddenly, when something goes wrong, those poor PHP developers don't need to jump into Rust on the next day. So standardized tech stacks are pretty cool at certain size, because suddenly your developers can move around and don't jump onto a steep learning curve. And the last thing I'd like to talk to you about today is don't repeat yourself abuse and shared libraries. That's quite a common scenario. So when you start going into microservices, you will probably, and you are building your second service, third, fourth, you will start notice some repeating patterns. So suddenly all those services probably have similar dependencies on class path. Some of those use similar DTO classes. So, for example, there is one component serving, list of users, and second consuming it. So now you need to somehow return it and receive it. So that sounds like one single Java, user class or so. So suddenly someone realizes, okay, there is repetition there, and repetition is bad because don't repeat yourself. Let's put this into a common module. Common, shared, utils, libraries, engine. I've seen many names of those. And that module over time starts growing. Suddenly someone realizes that, okay, we do repeat this Spring Boot version. Let's put it in there. Okay, but some modules, they use Spring AMQP and Spring Cloud and Spring something else. Okay, let's put it all in there so that my dear colleagues don't need to include their own dependencies by themselves. We'll save them time. Okay, DTOs, well, they do repeat. Let's put them in there. At some point, someone notices, okay, but there is this logic in there, in those two services, which seems more or less the same, which is, by the way, probably an indication that the split went wrong. Let's take this business logic and put this into a common module because, well, it's reused and, well, we shouldn't repeat ourselves. And suddenly you have this huge common module with total mess on class path. And suddenly, when you make a really tiny change in there, you need to deploy all of those services that depend on it immediately. So what happens normally is that someone decides, okay, that's a really small change. We just bumped a bug fix version on some irrelevant library. Let's not deploy all 80 services that depended on that because, well, that couldn't break anything. And that's how the drift begins. The difference, so suddenly the difference between the version working on production versus the new version of the common module becomes bigger, bigger, and bigger. And imagine, for example, in the Spring Boot world, there's quite a lot of magic happening when it comes to class path scanning. Spring will do quite a lot of magic based on the content of the class path. So now, you have this common module, which triggers quite a lot of Spring Boot auto configurations. You suddenly update one of the dependencies, which triggers a whole, a Christmas tree of updates in transitive dependencies. And suddenly, some of your Spring Boot auto configurations stop working. But you don't know that. So, and in those services that you didn't really deploy, because you didn't really want to, because you thought the change was innocent, you didn't do that, but now you need to. So you upgrade a small version, and it blows up. Apparently for no reason, which ends up in weeks of debugging. So that's not fun. I'm not saying you shouldn't use shared libraries, but when you do, treat them as libraries and not big bags of code where you can literally put everything. Make them small and narrow, version them, and literally treat as libraries. And like never put business logic in there, because that's usually a bad idea, pretty much always. So that's where people normally ask, so I need to consume REST API for other services. Do I create my own DTOs? Generally, yes. You want to couple to a contract and not to Java classes. Ensuring that contract matches by sharing Java classes is not that terrible of idea, but there are better ways. So for example, contract testings. Or if you are using OpenAPI specification, you can auto-generate your own classes from the contract so that you share a contract and not classes by themselves. And at the end of the day, even if you need to create those two sets of classes for two services, you get independence at the expense of writing a couple of lines of boring code. And that's usually a pretty good trade-off. So you feel bad because you've written a couple of lines of boring code, but now you're independent from some extra common module or so. So that's all for today. I'd like to remember just a couple of things. Do not start with microservices. Start splitting them when you actually feel when you're experiencing problems. If you start with microservices, you are quite likely to experience more problems from the split than from your monolith. If you've done your split already, and now you're working with independent systems, stop pretending like they are the one. If you try to release them together, if you try to tag them together, version them together, you are quite likely to experience more problems than benefits of that setup. And that's quite often the sign that probably the split was premature. And guess what? We are now prone to all the fallacies of distributed computing. Start thinking about cup theorem, at least once versus at most once, because you can't really have exactly once. Suddenly you need a lot more things to worry about. You need special monitoring. You need idempotency of your customer, of the clients that consume events and APIs. That's tricky. And and pay a lot of attention to the guarantees that your system provides. At most ones, in most cases, is not good enough. And so if you can drop some events, if they can never arrive, some of your view models can be permanently broken. You don't want that. And at the very end, think about adding new tech when there's very good reason to do it. In most cases, this can be driven by some non-functional requirements. So for example, the message relay I've told you about earlier, the one that picks messages from a database and sends them over to Kafka, that's a great place for a Golang to be used instead of Java. Well, it starts immediately. The Docker image will probably have around 10 megabytes of RAM. Starts immediately, works great. But in most cases, you don't want to put new tech in there just because you can. Don't get me wrong. Very good reason to do that is to learn. So if you make, for example, conscious choice that, okay, we have this Slack notification service in there, but we're writing it in Rust for the sake of learning Rust, that's okay. But not just because we just felt like it, we've rewritten everything to Rust, PHP, and JavaScript. So that was all I've had for you today. If you want to, you can read the presentation out in there. And if you want to find the presentation itself, it's also available under this QR code. So thank you very much. I don't think we have a lot of time for questions. So, but if you want, just feel free to catch me. I'll be around here for some time. Thank you.